from Dragon. A couple of seconds later, you see the drogue chutes coming out. It will slow down on the way down, and then you see the main chutes coming out, and then it's going to gently land on the water, probably 1.5 minutes after the ignition. There's going to be a bunch of boats waiting for the Dragon, where we recover it and then process it from then.
Yeah, Hans, I'm like you. I'm very excited to be here. These are the kinds of things that in rocketry that we live for, these dynamic, very visual sorts of things we're going to go do. We've been working towards this point for more than 4 years since SpaceX outlined the test in our Space Act agreement we have with them, the CC-ICAP agreement. It's not like we woke up a few months ago and said, hey, what would be really cool? No, like I said, we've been planning this for a very, very long time. A lot of folks putting a lot of effort into this. It is rocketry. Like I said, these are the days in this business. It's really cool. You've worked very hard. You've done your calculations. You've done all the really nerdy things you get to go do, and now there's going to be some smoke and fire, the part that we really love. This is not, this is a development test. Okay, we are developing a system. We're looking very hard at how the Super Dracos will operate during this test. This is not a shiny, well-polished space shuttle launch. SpaceX is actually pulling back the curtain a little bit to let us see and let you folks see exactly the nuts and bolts of going and doing a developmental test. So, like I said, it's not perfect. They haven't gotten their pencils out and sharpened every single corner of the performance box. This is, let's go test. Let's get out there, and one good test is worth 1,000 expert analyses. That's the thing. That's why you go test, and SpaceX has a definite test philosophy that I tend to like. I don't want to exclude anyone. You always do when you do this, but there are certain people I do want to mention that I think have been really critical in getting us here. On the SpaceX side in particular, I know Dean Ono and Matt McCown out at SpaceX in developing the Super Draco engine have been incredible. And of course, the leader of the test coming up, Kiko Donchev, he has done an amazing job getting this thing to where it has to be. And on my team, on the NASA side, I couldn't have helped herd us to this point without the help of my chief engineers, Chris Lupo and John Posey, and then up at Marshall Space Flight Center, Adam Butt, who is our propulsion guy and really knows the Super Dracos very well. So, like I said, we're very excited. We can't wait. Wednesday won't get here soon enough. I can assure you that there's a lot of work to get done between now and then. And we're going to see that it all gets done correctly, and then hopefully Wednesday morning, 0700. So I have nothing else to add unless you do, Hans.
Well, I just want to mention David Giger is also the program manager of Dragon, sits over there, and he's pushing his team to this huge effort over the last couple of years. I personally think it's the coolest looking spacecraft you can see, and yeah, that's the main thing. I'm really excited about this.
Okay.
So at this time, we'll open it up to questions first in the room and on the line. If you have a question on the line, we ask that you press *1 before you ask a question. And in the room, we will pass the mic to you. And if you could state your name and your affiliation, that would be very helpful.
That'd be very helpful.
So we'll go ahead and start out with Irene.
Hi, Irene Klotz with Reuters. A couple questions for Hans. Can you describe a little bit the setup at the pad for this test, what you built to host the Dragon on? And then, we're used to seeing a Dragon fly and use the thrusters and everything, so maybe you could explain a little bit about what's never been done before as part of the test.
Yeah, so the pad is a big hole, basically, right, with the flame duct. And for the rocket, we have this big transporter erector that we put over the hole. And if you imagine not having the top part of that, but having the bottom part basically rebuilt, and that's pretty much what we did. We have a steel frame that covers the hole and has a simulated upper part of the rocket basically on top of that, and then the trunk, which is the between Dragon and the stage, sits on top of that. It has fins. You see this very prominently, and then on top of that is Dragon. So it will be released from this stage extension part at liftoff, and then the flame duct will take the flames largely. Second question was What's new?
The maneuvering, right, the
Yes.
firing of
So-
the thrusters, and
Right.
basically what are you trying to demonstrate with this test that's different
Right.
from what we'd see during a returning cargo Dragon?
Yeah, so if you look at traditional launch escape systems, there's actually one just outside the building here, and those are solid rocket motors. They're sitting. There's the first part of the rocket when it launches, and in case those are used, they're going to ignite, blast the capsule actually, but pull it out and get it away. That's the idea behind the traditional launch escape towers basically, and it's huge. If you look at the system out there, that's a big system, and incidentally, you have to get rid of it before you get to orbit, right? Because otherwise you have the system in orbit. So every time you fly, you have a separation event that is very critical. And yes, the launch towers provide safety, but then there's also this critical event. So it's kind of like a trade. We, on the other side, we have a liquid propellant system. And the propellant you use in orbit or potentially for a landing, you can use that same propellant for launch escape or on abort, basically. And then use your parachute for landing, or because you don't go to orbit, you don't need the propellant in orbit anymore. So it basically uses a propellant that you have anyways on board. That makes it lighter, and it also, because you don't have the separation event, you don't have to throw it away every time. You make it to some extent safer. It's integrated into your system, so you have redundancy in the system that you also use for other parts. So I think overall it's the more integrated approach, it's the more sophisticated, modern approach, and in my opinion, it's also the safer approach to launch escape. It basically closes a loop on some of the rockets. There are times when you can't get out, and on this particular vehicle you can always get out. Whatever happens to Falcon 9, you will be able to pull out the astronauts and land them safely on this Crew Dragon, and that is, in my opinion, this will make it the most safe, the safest vehicle that you can possibly fly.
I want to add one thing, Irene, that's kind of a distinction between this test and what you might see on an actual launch day. Of course, there's no actual rocket sitting underneath the Dragon in the trunk this time. We'll be launching almost from ground level. So one of the things we're doing different is there will be water coming in from the side, because if you're way up high, you don't have to worry about ground effect noise, that sound coming back and hitting you as hard. So for the purposes of this test, we'll also be using some sound suppression water. So that's something you'll see. It's a little different than normal.
Jason Ryan for SpaceflightInsider.com. This is going to be kind of playing off Irene, but directed towards John. John, we've with Mercury and with Apollo and with Soyuz, we got very used to seeing a last use, and I see that we're going to see this new system. What has been NASA's reaction to this new system, and can you give us any specific aspects of what NASA has looked at when it's looked at the new launch abort system for Dragon?
The launch abort system comes from a requirement we have for loss of crew, or LOC as we like to call it in the business. How you accomplish that, so that's part of the reason for commercial crew, is let's go be innovative and see what other people are thinking. And there are different ways to do business. And so that SpaceX came up with this way, we think is fantastic. We see inherently there's nothing wrong with going and putting the rockets on the side, and as Hans has pointed out, you get some benefits from doing that. You can eventually, they hope someday, to be able to do a propulsive landing. If they don't have to do an abort, they can use those same rockets for a landing. Whereas if you had an additional launch escape system on top, once you get up above a certain point, you would always blast that away. And that's another point that Hans made, which is you can use these abort engines all the way to orbit, whereas with the old Mercury and Apollo launch escape systems, you got to a certain altitude and you jettisoned it. With this capsule, you have the ability all the way to orbit to get away from something that's malfunctioning beneath you. So we see no inherent problem with doing it this way. It's innovative, and that's really part of the whole reason we're doing commercial crew. Let's go learn to do business a new way a little bit.
Jay Patterson with CTNewsJunkie.com. Can you give us some information on the test measurements that you're going to take on this during this? What type of information and how many channels you're measuring?
Oh, I don't know how many channels themselves, but it's going to be there's a lot of instrumentation on this vehicle, a lot, and we measure vibration. There's vibration sensors, 3-axis accels, basically, obviously attitude. There's several gyros on there. There's load cells in some of those parts. Temperature sensors on the outside to see how the heat flux changes. Acoustic sensor, microphones. How's the environment for the astronaut? There's a dummy in there that is equipped, and we will see how the dummy will do.
Right.
Let's see. Did I forget anything? This is basically a flying instrumentation deck.
Yeah.
At the end of the day.
There's a lot of instrumentation in the trunk.
Right. And it's actually there's a transmitter, but you have the luxury. It doesn't go very far at the end of the day, so you can actually save data there. And there's also a lot of cameras.
Right.
Those cameras are going to create hopefully really cool pictures.
Exactly.
So I'm pretty sure when we get it back, there's going to be lots of data analysis, lots of cool pictures and new data for that at the end of the day is the point of the test, right? We collect data, we see how it goes, and then we will see if we have to make any modifications or if you can fly it right away, and we'll see. That's the test part.
It's exactly it. The data is the thing that they're going to use some of this data towards their certification, and that's the big thing. Let's go get a lot of data, and whatever is applicable towards certification, that's what they'll go use. So.
Sorry to bother you guys again, but I was just thinking, with this flight, we're looking forward to crews returning to flight from Kennedy, from Cape Canaveral. Can you talk a little bit off topic about what's being done, or is anything being done? Is it already designed from the beginning, the Merlin 1D, to get it to be crew rated? Was it designed to be crew rated, and is it built that way from the beginning, or is it any modifications going to be need to be made to the Merlin 1D to make it to be able to launch crews? Thank you.
Yeah, so 1D, actually 1D and the Falcon 9 was always crew rated, and to me this looked always a little bit up, and we never let any doubt on it. We recall the first optimistic, right? But as I said earlier, the goal of SpaceX was always human spaceflight, and we never let any doubt on it. We recall the first Dragon capsule was, after all, a cargo ship that had a window. Yeah, and that was our way of saying, look, we're ready for astronauts. We just we just need some help with it. And so there's certain safety factors that you have to keep, and those are already worked into M1D and already worked into the vehicle. So right from the get-go, it's interesting because the way this works out is that for Dragon, the loads are different than for fairing, so you actually don't lose any performance. It's actually it's right on the money for that what you would have for pure satellite missions, anyways. So it worked out well. We have the right safety factors in there, and we're now in the process towards certifying both vehicles for manned spaceflight.
Irene Klotz with Reuters again. As far as the firing of the thrusters in the atmosphere, when the Dragon cargo ship is returning, is there ever a time that the thrusters are firing for maneuverability or steering? I appreciate the response that you gave about how this operates as a launch escape system compared to a tower. What I was asking about as well is the operations to perform abort scenarios compared to how you already are using Dragon in space operations.
It's definitely different to run thrusters in air under atmospheric pressure. In this particular case, the Super Dracos are big thrusters. They're really big compared to the Dracos we fly on Cargo Dragon. And the Dracos are actually on the Crew Dragon too for attitude control and for the fine orbital maneuvering that we do in orbit. These are total thrusters are 120,000 pounds. So it's just it's a lot of kick, yeah. And for example, what we haven't done is we haven't run all of them together. So this will be the first time we actually run them together. The integrated propulsion system will run for the first time on this test, basically, and that of course is a big deal. It's a test that is elaborate. We got to be careful. It's hypergoals after all, so a lot of things have to work to make this test successful. Like John did, I want to point out it's a development test. It's a brand new vehicle. It's a very complex vehicle. It's been in the works for a long time too, and tests go this way or that way. So I just want to lower the expectation. It might be we need more time, and it might be that we need to troubleshoot on certain things. But overall, this particular, I don't expect any issues on the propulsion system just because it is in the air, because we test them usually in ambient pressure too. But it's a different application than from the in-space application, obviously.
Let me point out a couple of really kind of neat things about the Super Dracos. As Hans alluded to, the most we've ever tested together is 2 SpaceX folks out at their McGregor facility, and this will be the first time all 8 have ignited at the same time. To me, one of the coolest things about the Super Dracos is they are printed engines. These are 3D printed engines, and the folks back at Hawthorne and McGregor working together have done an incredible job to develop this engine very, very quickly. They went through a lot of iterations of the design, some of which were not printed, and they finally settled on this one, and all indications are it's going to do a super job.
Is there a guidance, navigation on the vehicle, and what sort of range safety
It's just whatever we feel like doing.
systems are there going to be kind of as part of this?
Guidance is running, and guidance and control obviously is one of the things we test in of the integrated system. From the range safety perspective, there's a certain amount of propellant on board, and it can go so far. Right. And we just clear the whole area, make sure nobody's in that circle, and then we do the test. So range safety wise, it's a pretty simple device. It can't get. No, there's no distract on it, and it can't. I don't want to say it can't get very far, because I think it actually can get pretty far, but you know what I mean, right? Compared to a rocket, it can't get very far.
Right. I think they're looking at a 2.2 mile radius clear on test day. Right.
Lane Harmon, SpaceheadNews.com. SpaceX is doing a lot of development, so this is more for Hans. On April 16th. Gwen Shotwell actually said that she didn't want to land on a barge anymore, that she wants to land on land. On the 18th, Elon said that through a Twitter that he wants to try the barge again in June. Any further comment on that?
So at first they're drone ships, right? But it depends on the range and whether we have approval to do this. And so, depending on which flight they were talking, they might have both be right. There are 2 flights right now where we work on returning to land. But it is correct that we do want to go back to land, because the drone ship is expensive, obviously, and you need to pull back pull it back for a couple 100 miles, and takes time. Weather is a problem, and just coming back to land is actually, that's what you want, right? You want to have a land. We have a landing site here, landing site 1, used to be LC-13 down there, and so imagine you land down there, you check out the vehicle, you break it over, you bring it up to the launch pad, and you launch it again. That's the vision, yeah. And obviously the barge is the drone ship. The drone ship is something that we did because it takes less performance of the rocket, and it's something that is from a safety perspective easier to do, but it's an intermediate step. Yeah.
Hi, Stephen Clark with Spaceflight Now. A couple of questions. First for Hans. Can you go in a little more detail about the flight sequence and the parameters of the flight? What altitude do you reach? How far offshore do you splash down? What's the recovery plan, etc.? And also, for either one of you or maybe both of you, What are the success criteria for this test? What do you need to see from this test to be able to move forward and be comfortable with the performance of the abort system? Thanks.
So the vehicle goes, the nominal trajectory is going to 4,500 feet altitude, and the landing point is about 6,000 feet to the east. But what you will see is when it takes off, it will pitch slightly over to the east. Is that east? I think it is east. And good point, yes. Towards the ocean, it will really burn short. I mean, it's a 6-second burn. That it will be over by the time you hear it, and then the coast goes pretty quickly too. When it reaches the 4,500 feet, you see the trunk separate. Then a couple seconds later, you see the drogues come out. Drogues will catch. They're reefed, so they have 2 reefing stages, I believe. So you will see them getting bigger. It takes half a minute, something like that, and then you see the main coming out and deploy also in 2 reefing states, I believe. Yeah. No, it's 3. Yeah, it's 3 main parachutes, 2 drogues.
3 mains.
Yes. and then you see basically watering. From a test success, there's a whole list of criteria that what we want to see. But you know, the test can be successful even if parts of the tests are not successful. Yeah, because we do have we have the in-flight abort coming up later this year. So there are certain things we can repeat on this particular test. To me, you want to show that you can move the astronauts away from wherever the problem is, yeah, and land them safely. That to me, that demonstration is really one of the key parts, together with gathering data that can improve the vehicle or show we did a perfect job. Somewhere in between those two.
There's all gray areas of success. I mean, even you folks, our friends in the press, you like to refer to Apollo 13 as a successful failure. So you can, in the midst of problems, it does not have to be flawless for us to call it successful. The point is to gather data. Now, obviously, you know, perfectly successful is exactly as Hans described, but we can live with something less than perfect, and no matter what happens on test day, we are going to learn a lot, and that's why we're here. This is a development test. I can't emphasize that enough. Let's go learn. We're just big kids with expensive toys, I guess you could say.
So with that, we're going to go to a few quick questions on the line and come back for questions on the room. So we're going to go to Tariq Malik with Space.com.
Hello. Thank you very much for doing this today. My primary question, I think, maybe for Hans, and I have a quick follow-up. Hans, I'm just wondering, for this flight, how fast is the Dragon ship going to be going? Do you have an estimate on what G-loads your dummy is going to see? And does the dummy have a name? I guess, does he have a nickname at SpaceX? Thank you.
Let's start with the easy part. The dummy's name is Buster. The G load is roughly 4 to 4.5 Gs, and it is early in the morning. By the end of the burn, at the end of the 6 seconds, you're going between 150 to 180 meters per second, and that is times 2 for knots. So it's about 300-ish knots. So you're going pretty fast for the fact that you only stepped on the gas for 6 seconds. That's probably faster than Tesla.
Going straight up, yeah.
Maybe. And did I answer all your questions?
Yes, that's great. Well, just one final quick one was, how will SpaceX be reporting out the results of the test? Will there be just a release, or are you planning a briefing later in the day? Just how do you plan to share that information? Thank you.
Honestly, you put me on the spot. I don't know. I'm pretty sure we will communicate somehow what happened and how it worked out. But I have not seen any plans.
Okay, we have another question. James Steen from Florida Today.
Hi, thanks. I have a couple questions. First, thanks for all the description of the flight profile. I was just wondering if you could, and maybe it's a little weather dependent, but I was hoping to be able to convey, like, the people out in the community who are going to be interested in watching, who may not be right up close. Do you think this is something that they will easily be able to see? Will they see smoke and fire pouring out of the Super Dracos, or will they just see the chutes? Or can you just kind of give a picture of what, you know, people around the area could potentially be able to see?
I'm pretty sure you can see it. I mean, it's going to go up to 5,000 feet, and we're gonna separate the trunk there. So at least that. As I said, don't wait for the sound, because then it's probably gone.
Right.
No, I'm pretty sure you can see this and get an idea on how high it goes, and maybe see the drogues come out too.
Right.
Yeah.
I think you'll probably be able, as Hans suggests, I think you'll be able to see as it's getting up into the atmosphere a little bit during the last 2 or 3 seconds. It'll be well clear enough. You'll be able to see some of the smoke and fire, and then there's a little bit of residual that occurs as it cruises on up in its trajectory. You should be able to see the trunk separate. That should be clearly visible, and you'll definitely see the drogues, and I'm pretty sure you'll be able to see at least the mains get through reefing one before you're in one of the clear areas, before you see it disappear below the horizon.
However, I mean, there's a webcast. It might be more convenient to do this from, it's Wednesday morning, 7 o'clock, so from your office.
Yeah, yeah, it's sunrise about 6:45, somewhere in there that morning, so right after sunrise.
So the webcast also keeps you informed. It's a long launch window. It's it goes from 7 to 2:30, I believe, in the afternoon. So, and bear with us, as we said, this is a development test. You want to make sure it goes well. So we might wait for the right moment. We might check things again. We might need more time just to get it done. That's why the launch window is so long. Yeah, and don't get upset when it goes later.
We don't have an orbit or a space station to catch.
Right,
so
exactly. It's not an
we're take
operational
the
launch.
time we need to do this right.
Yeah.
John, just kind of continuing for a bit on the historical context here, I wondered if you could say, I mean, to your knowledge, have we ever seen a test like this of a crew capsule abort system from Cape Canaveral? And furthermore, I guess I just wondered if you could, you talked a little bit about the sort of difference of the pusher system from traditional systems, if you could maybe just put it in the context of in comparison to shuttle, which didn't have this abort capability at all, whichever system might be used, how presumably it's a significant improvement over that, and I don't know if you could translate that into any the probabilities at this stage of loss of crew and things like that, but just sort of safety improvement relative to shuttle.
Boy, James, you're full of question this morning. I'll try to get to it, and you let me know if I don't get to all of your points. Historically, since I regret I wasn't here for Mercury, Gemini, and Apollo. I would have loved to have been here back there in those days. I don't personally recall launch abort system tests from here. Now, as far as a pusher system goes, I know up at Wallops they did a pusher system test up there at one time. But this, to my knowledge, what SpaceX is doing is the first time we've seen anything, certainly from a side-mounted. This is revolutionary in that regard. On a side-mounted launch abort system. Correct, back during shuttle, we did not have a launch escape system. You got to remember when the shuttle was developed. NASA was very much feeling its oats. We had just gone to the moon, which everybody said was impossible, and so we designed a spaceship. We thought we could design a spaceship that did not need one, and we did. And as physics and nature will sometimes do, they taught us a lesson that maybe you should not go do that. So our lesson learned out of shuttle, while it was a tremendous, and we tried to build the reliability into that so that we wouldn't need that. You can get even better loss of crew numbers if you have an escape system. So our lesson learned coming out of shuttle was, let's go do that. Let's buy even more safety for the astronauts than we had. Let's not just build it in. Let's also have an escape system. And in the commercial crew, that's where we were coming from, because you've got to remember when commercial crew started, Our objective was not to get astronauts to the space station, but to enable the private sector to develop rockets and spaceships to carry anybody into space. It is only since we've been in for a few years that we have come to the ultimate goal of now we're thinking about procuring them to take our astronauts to the space station. So if you're going to develop a private sector capability, let's make it as safe as possible for anybody, because as you folks well know, I think we're doing something historic here. What I like to tell people is if you believe in the future where 2, 3, 4 generations from now, our kids, grandkids, great-grandkids go to a spaceport the way you and I go to a airport right now, and they get on a rocket to go fly somewhere in the solar system or hopefully beyond, the DNA of that private sector capability will be in what we are doing in the Commercial Crew program with SpaceX and with the Boeing folks right now. And so that's what gets me excited about being a part of this. I can't imagine doing anything else right now. I love this. So did I get your questions, James?
Yeah, thank you.
Okay.
So with that, we'll go to Robert Perlman on the line with CollectSpace.com.
Hi, thanks. A couple of questions. For Hans, you mentioned that Buster's on board. Can you describe how he's seated? Is he seated in the same type of seat that astronauts will use, and how many of those seats are on board? And what are his surroundings in terms of is there a mass simulator for the control panel or an actual control panel? And how much weight are you carrying in terms of equivalent for a crew?
So I've seen a picture of Buster in the seat. He's very comfortable, and he's tied down like an astronaut. So that is very similar to that. I've seen masses or mass dummies, like basically aluminum, I believe, for the other astronauts. So we replicate the weight on the seats. You know, just the way it would be for astronauts, I guess, heavy and light astronauts, I presume. Your question about the control panel puzzles, I think I saw the control panel. I think it's not in there. Okay, it's not in there. So we simulate largely the astronaut masses. We will, you know, obviously the response of all the forces on the astronaut is one of the key things we measure. And we will check with Buster after the landing how he feels.
I hope he's comfortable. He's already been in there for a long time, and he's still got a ways to go.
It's true, yeah.
And just a quick follow-up in terms of after splashdown, where do you bring Dragon back to? How long do you expect it to take to get back to port? And then once it's back at port, where does Dragon go from there? Are you doing the post here, post in Florida, or does it go back to Texas or California?
It's going to go back to Texas, and we will do some more detailed inspections in Texas. But we will do the immediate operations on a barge, and in this case you can say barge out there. It is a barge. It has no engines. Yeah, and it's right now regarding the port. This is in works. I don't think we've finalized that. We have a couple more days to go.
Okay, thanks.
Okay, with that, I believe our last question on the line is from Marion Kramer with Mashable.
Hi, thanks very much for doing this. So I have a couple of quick questions. First of all, I know that the test is very short, but is there any chance that we'll be able to see footage from some of the onboard cameras as the Dragon is flying? And also, if all goes according to plan, how long until the next flight for the in-flight abort? Thanks so much.
Yeah. So the first question was, can we see the video on the outside? I'm pretty sure we'll see how the video is, and if it is good, then we've been in the habit of publishing our cool and not so cool videos, and I guess we've been pretty open with that. So you can bet on that. It's going to be some cool pictures, I'm pretty sure. Okay, the second question regarding the next test with it. So there's a plan. The plan is later this year, or in summer, basically. But I must also say it depends on how this test goes and what we actually find out in this test, whole purpose of the test. We also need to make sure that the capsule goes in sealed salt water, so we're going to rinse it. We've got to make sure everything's fine, everything's good to go. So that schedule is planned right now for later this summer, but like for the test itself, bear with us and give us the time to work this out safely and diligently, so that the next test is going to be a success then.
Yeah, Kiko and the talented folks here, when they get it out of the water, they're going to look and see if any. They've tried to seal it up so that no salt water gets in. I'd be willing to bet some will. They'll rinse it off, and that's the big thing. Let's get it back to McGregor, decontaminate it, take a look at all the components, see how they fared from the test. That's a big thing, and then that's what tells you when you can be ready to go do the in-flight abort test, which we hope is later this year. That's the plan.
Great, and that same capsule will be used hopefully for the in-flight abort as well. Just to confirm.
Yes.
Yeah, that's it.
Yeah, it's the same cap. We will fly the same capsule on both tests.
Mm-hmm.
Thanks very much.
Okay, with that, we'll go back to Irene here in the room.
Thanks. On the in-flight abort test, at what altitude are you currently targeting to release the capsule?
Yeah, the in-flight abort is actually, that's a test nobody has done before. I just want to point this out. At least I don't remember this. Well, I haven't read anything about this.
Okay.
So the in-flight abort happens at max Q, which is the critical phase. Actually, that's where many things, the loads on the rocket are pretty high. That's the highest max Q. And that is typically at like 13 kilometers. That's about 40,000 feet altitude. And the in-flight abort will mimic this. It will go to the right altitude and to the right speed to replicate this particular situation, which is pretty elaborate. It's a very elaborate test.
Let me explain, because we use this term all the time, and no one ever really explains it. Max Q. It's maximum dynamic pressure, but so the dynamic pressure is a combination of, so as you go up in the atmosphere, obviously the atmospheric pressure gets less dense, it gets thinner, but you're also ramming into the air much faster because you're accelerating through it. So the combination of the static air pressure as well as the pressure of the air you're running into faster and faster, it reaches a point like this and then it precipitously falls off. And so max Q is where when you try to get away from the rocket, it's going to try and suck you back to it the hardest, and it's trying to stop you. Just the pressure itself is trying to stop you, but also the vortices behind it are trying to suck you back into the rocket. So that's why we do it at max Q.
Thanks. And an astronaut band. In the CC Dev program, Blue Origin tested a pusher escape system. Can you, John, maybe talk a little bit, or Hans, about how this system is different?
I'm going to have to confess I don't know much about their pusher escape system, so I really would have to do some research. I am not qualified to answer that question. I'm sorry.
Yeah, me neither. I have not. Was that like a test like a year or 2 years ago or something like that?
Yeah, 2012, I think.
Yeah.
Yeah.
It looked good on video. I saw that. Yeah. So I do remember that.
On the in-flight abort, is there any reason why you're doing that in California?
It's mostly we're really busy here. We've had 5 launches in 4 months this year, and
there's no let up.
Right, it's just hard to put this in between. And in Vandenberg, there's more schedule availability. Primarily, it's the shorter commute too.
And just to give you an idea, I told you earlier we're launching this from the ground, not on top of rockets. So one of the things they have to do that affects them is they've got to remove the catenary wires that are above the pad. And Kiko, are they done doing that? In process. So therefore, they got to go remove those wires, because otherwise the normal trajectory from a ground-based launch abort test would fly through those wires. Now, if you're on top of a rocket and that were to happen, we're smart enough not to go through the wires. But
there's still some wires there. It's the inner wires that go away.
Right.
Yeah. Right. So there's still lightning protection.
Right.
Rick Lansby with WFIT Radio, public radio for the Space Coast. What factors would the weather play on Wednesday?
The weather will be great, just like today. We have no weather guy here. So wind, of course, is the main concern. If the wind comes on the wrong side, we may not be able to launch. In particular, if we have high winds onshore, right, is this direction? That would cause us to wait. On the other side, it's pretty unlikely, and after not being very cooperative for the last couple launches, I hope the weather will make it up and be really nice and have the right wind direction for Wednesday. But yeah, it depends on the weather.
And that's one of the reasons they're doing it at 7 o'clock in the morning, because this year we seem to have gotten into an earlier summer pattern, and so let's do it in the morning before anything has time to build up potentially.
Yeah, if I want trouble, I do it at 4 in the afternoon, right?
There you go. Okay.
Are there any other questions in the room?
Hi, Stephen Clark, Spaceflight Now again. Just a quick one. What's the mass of the spacecraft or the vehicle that you're going to be testing?
So the whole stack is 21,000 pounds. And then there's 3,500 pounds per pound of that.
Real quick one, Jason Ryan, Spaceflight Insider. How far do you think that the Dragon will travel out into the Atlantic?
So the nominal distance, also depending on the wind, of course, but nominally it's 6,000 feet, about a mile. Yep. And it puts you, I believe the shoreline is right at 3,000 miles. So it puts you 3,000 feet. So the shoreline is 3,000 feet, and we're going 6,000 feet, so it puts you safely into the water.
Okay, with that, we'd like to thank Jon and Hans for taking time out of their busy day to join us today. We are just as excited as they are to have this Pad Abort test go off, and we can't wait to see the Crew Dragon take flight. The test will be aired live on NASA television, and we will start coverage about 25 minutes before the test. We'll also be blogging live on blogs.nasa.gov/commercial crew. Thank you so much for coming, and we look forward to seeing you then.
This is not. This is a development test. Okay, we are developing a system. We're looking very hard at how the Super Dracos will operate during this test. This is not a shiny, well-polished space shuttle launch. SpaceX is actually pulling back the curtain a little bit to let us see and let you folks see exactly the nuts and bolts of going and doing a developmental test. So, like I said, it's not perfect. They haven't gotten their pencils out and sharpened every single corner of the performance box. Let's go test. Let's get out there, and one good test is worth 1,000 expert analyses. That's the thing. That's why you go test, and SpaceX has a definite test philosophy that I tend to like. I don't want to exclude anyone. You always do when you do this, but there are certain people I do want to mention that I think have been really critical in getting us here. On the SpaceX side in particular, I know Dean Ono and Matt McCown out at SpaceX in developing the Super Draco engine have been incredible. And of course, the leader of the test coming up, Kiko Donchev, he has done an amazing job getting this thing to where it has to be. And on my team, on the NASA side, I could
see this very prominently, and then on top of that is Dragon. So it will be released from this stage extension part at liftoff, and then the flame duct will take the flames largely. Second question was what's new?
The maneuvering, right? The
Yes.
firing of the thrusters, and basically, what are you trying to demonstrate with this test that's different from what we'd see during a returning cargo Dragon?
Yeah, so if you look at traditional launch escape systems, there's actually one just outside the building here, and those are solid rocket motors. They're sitting. There's the first part of the rocket when it launches, and in case those are used, they're going to ignite, blast the capsule actually, but pull it out and get it away. That's the idea behind the traditional launch escape towers basically, and it's huge. If you look at the system out there, that's a big system, and incidentally, you have to get rid of it before you get to orbit, right? Because otherwise you have the system in orbit. So every time you fly, you have a separation event that is from Dragon. A couple of seconds later, you see the drogue chutes coming out. It will slow down on the way down, and then you see the main chutes coming out, and then it's going to gently land on the water, probably 1.5 minutes after the ignition. there's going to be a bunch of boats waiting for the Dragon, where we recover it and then process it from then.
Yeah, Hans, I'm like you. I'm very excited to be here. These are the kinds of things that in rocketry that we live for. These dynamic, very visual sorts of things we're going to go do. We've been working towards this point for more than 4 years since SpaceX outlined the test in our Space Act agreement we have with them, the CCICAP agreement. It's not like we woke up a few months ago and said, hey, what would be really cool? No, like I said, we've been planning this for a very, very long time. A lot of folks putting a lot of effort into this. It is rocketry. Like I said, these are the days in this business. It's really cool. You've worked very hard. You've done your calculations. You've done all the really nerdy things you get to go do, and now there's going to be some smoke and fire, the part that we really love. Couldn't have helped herd us to this point without the help of my chief engineers, Chris Lupo and John Posey. And then up at Marshall Space Flight Center, Adam Butt, who is our propulsion guy and really knows the Super Dracos very well. So, like I said, we're very excited. We can't wait. Wednesday won't get here soon enough. I can assure you that there's a lot of work to get done between now and then. And we're going to see that it all gets done correctly. And then hopefully Wednesday morning, 0700. So I have nothing else to add unless you do, Hans.
Well, I just want to mention David Giger is also the program manager of Dragon. That's over there, and he's pushing his team to this huge effort over the last couple of years. I personally think it's the coolest looking spacecraft you can see, and yeah, that's the main thing. I'm really excited about this.
Okay.
So at this time, we'll open it up to questions first in the room and on the line. If you have a question on the line, we ask that you press *1 before you ask a question. And in the room, we will pass the mic to you. And if you could state your name and your affiliation, that would be very helpful.
That'd be very helpful.
So we'll go ahead and start out with Irene.
Hi, Irene Klotz with Reuters. A couple questions for Hans. Can you describe a little bit the setup at the pad for this test, what you built to host the Dragon on? And then, we're used to seeing a Dragon fly and use the thrusters and everything, so maybe you could explain a little bit about what's never been done before as part of the test.
Yeah, so the pad is a big hole, basically, right, with the flame duct. And for the rocket, we have this big transporter erector that we put over the hole. And if you imagine not having the top part of that, but having the bottom part basically rebuilt, and that's pretty much what we did. We have a steel frame that covers the hole and has a simulated upper part of the rocket basically on top of that, and then the trunk, which is the between Dragon and the stage, sits on top of that. It has fins.